So I have a statistics problem, okay?
Mhm.
So the problem is that you have you have 11 buckets, okay? They're labeled from 2 to 12, and you have a bunch of marbles, okay? Let's just have an example where you have 36 marbles, okay? Now you put the marbles inside the bucket, and you can choose the distribution of the marbles inside the buckets, okay? And you have to put every single marble inside one of them, okay? So then what you do is you have 2 dice, and you roll the dice, and then you find the sum. So if I rolled a 2 and a 5, then I would have a 7, and then I would go to the bucket which corresponds to the dice. So I would.
Which is 7?
Yeah. So I go to bucket 7, and then I take one marble out. Okay.
Okay.
So after you do this,
How many times do you throw the dice?
You do it 36 times. If so it corresponds to the number of marbles you put in there. Okay.
Okay.
So then your goal is by the end, you want to have as few marbles in the buckets as possible.
Okay, so get the most hit.
Yeah.
Okay, so when you throw a dice, what's the probability of getting a 2?
Okay, so it's 1 in 36.
Because?
Because the only ways that you can get a 2 is by getting a 1 and another 1.
So what's the probability of getting a 4?
That's 3 in 36.
Okay, why is that?
Because so the first dice, you can get a 1, a 2, or a 3, right? And the second dice, I have to get this dice minus 4.
4 minus?
Yeah, 4
Okay.
minus. Yeah.
Alright, and then why 36?
36 because each dice has 6 sides, so 6 times 6.
Okay, so then for me the solution is to pile all the marbles into the bucket that has the most probability.
Yeah.
Right? Which one is that?
7.
7. Because?
Because the first dice, you can do any one of the 6, and then the second dice, you just have to do that.
Okay, so it's 6 out of 36, which is 1 over 6.
Yeah, 1 and 6.
So if I pile everything in there, then the probability of me getting a hit is 1/6.
Yeah.
So on average, I will have 5, 6 left.
Yeah.
Okay, but you have a better solution.
Yeah.
What is that?
So the solution is to take the distribution. So if you have 36, if you roll it, so you have 30. You roll the dice 36 times, right? So on average, it'll hit the 1 bucket 1 time, or the 2 bucket 1 time, the 3 bucket twice, and so on, right?
Okay.
So
you have a certain distribution.
Yeah. Okay. So then you put the dice according to that distribution.
The dice?
Or the marbles according to the distribution.
Okay.
Okay.
And why would that give a better result?
Because if you do this a lot of times, right? If you repeat this experiment like 1,000 times, right? Then the dice, it'll very closely resemble the distribution. And then once you put the marbles there, then you'll have the 2 lines. They're very close to each other.
Okay. So then if they match each other completely, then basically you get 100%.
Yeah, you get 100%.
Okay. So that's theoretical. But we want to see if that's the real situation or not. So how are we going to do that?
So I wrote a program in Python, and that does it for us.
It does it for us. Okay. So let's look at your program. Okay.
Yeah. Okay. So this is the code that I wrote. So right here, just import random for the dice. Now this is my first strategy, and you can read the comment. It's just a list of the markers or the dice for each bucket. Okay. So for the 0th bucket, I have 0. For the first bucket, I have 0. And
first bucket is bucket with number 1 or?
Yeah, with the number 1 on it.
Okay.
And this is the second bucket. Okay. Now the reason I have to have the zeros is it just makes it easier to work with the list.
Yeah. Okay. So strategy 2 is what?
And strategy 2 is the strategy where you pile all of the the markers or the marbles onto the bucket that's most likely to get hit.
Okay.
Okay.
So markers equals 36 on line 9.
Yep. So right here.
That's the.
So I just that's the number of dice and the number of times I roll the dice and the number of times the number of marbles. Yeah.
Okay.
So then I set the tally to the number of the markers.
What's the tally? That's
so the tally is how many markers or marbles are left.
Okay. At the end of
each experiment.
Okay.
Okay. So this is the total tally. So I just set the total tally for 0 because I haven't really done any experiments yet. So I have experiment time. So this just tells how many times I repeat this experiment.
So in each experiment you throw the dice 36 times.
Yeah. Okay. So right now I'm doing it 10,000 times. So this it just loops 10,000 times. Marker equals strategy 2. Okay. So that just sets the variable marker to the strategy 2, and tally equals markers. So we just set the tally to markers again because we have to repeat the experiment. Okay. So for X in range markers, that just repeats 36 times, and this just gets a random dice throw. So we look at the bucket where the dice is, and we check does that bucket have one or more marbles in it. If it does, then we make the number of marbles in that bucket 1 lower, and we decrease the tally by 1. Okay.
So at the end of the one experiment, you're gonna have tally equals the number of marbles that are left.
Yep.
Okay, and then you do what?
Total tally. And then I add that to total tally.
Okay.
So over the experiments and the total tally will add up.
Okay.
Okay. And then at the very end of all 10,000 experiments, I just divide this by 10,000.
Okay.
To get the average.
All right. So then you want that number to be as small as possible.
Yep.
So now we do strategy 2, which is the thing where everything is piled onto one.
Yeah.
Okay.
So we have 29, almost 30. Okay.
Okay. So which matches our thing, right?
Yeah.
Our prediction is what, 5, 6?
Yeah.
Right. So the hit is 1, 6. So what's left is 5, 6.
Yep.
Okay.
So then if we try strategy number 1, then 7.0.
Okay, so we have a lot less left.
Yeah, it's a lot more accurate. And I think that if we increase the number of markers, then it will become even more accurate until this thing's...
it converges down to 0?
Yeah. Well, the only problem is that because we have more markers or more marbles, then it won't. It'll actually increase. But if we divide it by the total number of markers, then it'll slowly converge to 0.
Okay. So let's try that. Let's increase the number of markers by 10 times.
Okay.
Let's make it 360. All those numbers 10 times more. Okay, so let's try this strategy. It's going to take a long time this time.
Yeah, it's going to take quite a long time.
Well, hopefully not too long. Last time it takes like a second, couple of seconds.
Finally. 22.93. Okay? So this is actually pretty good because the number of markers has increased dramatically.
It's increased by 10 times.
Yeah.
But the number of marbles you have left doesn't increase by 10 times.
Yeah, it doesn't increase by 10 times.
Okay. All right. So now let's see what's the other strategy, the
Okay.
the simplistic strategy.
Okay, so the simplistic strategy. Okay.
And what do we expect this thing to be?
We expect it to be, well, we expect it to be similar, like 10 times.
10 times. That's
what it
about
used to be.
about 300.
Yeah. So yeah,
Yeah.
that's pretty close to 300.
Yeah. Okay. So obviously your theory is correct, and then the bigger the number, the smaller it gets. It gets even better with larger numbers.
Yeah, for the first method.